Oh, yeah. What? Oh, hi. Oh gosh. Hi. Sorry, spontaneous stream today because I want to get more streaming in, and apparently Body decided it was going to be a good day to feel awful, but we're doing it anyway. Um, hopefully everyone's doing okay. So the plan today is pretty simple. Pretty simple, actually. So the general idea is we have the pinouts coalesced for the... Oh, hi, Vester. Wow, 29 months. Whole streak. Thank you so much. Wow, it's a long time. Where was I? What was I saying? Yes. So we have the SCSI pinouts. Oh, hi. We have the SCSI pinouts sorted and coalesced into a singular document. So now the general idea is we need to take those pinouts and then actually do the connector assignments and schematics, and then we do the layout, and that's all the connector board's done. We still have to finish the LVD5 board. That still needs its termination power LDO, as well as some other bits, and then layout. But those are the two big hardware things that are left on Squishy. I'm currently waiting on Esden for Squishy board assembly, and once that's done, hopefully we can move on to more gateware soft stuff, right? Let me switch to... That's the wrong one. Here we go. Yeah, so this is the pinout document that has been assembled. It takes every... Oh, Annie wants to say hi. Annie, out of the way. It takes every SCSI standard and every pinout table in every SCSI standard, and then every connector standard in every SCSI standard and every variant of those connectors. And what we have done is we've assembled a big table, right? So then we have the table reference inside the standard, and then we have a table ID here. So what's gone on is we have extracted all of the pinouts, so all the pinout tables for every connector and every standard. And then what's gone on is we've deduplicated and merged all of these into common pinout tables, right? So this document is like 2,000 lines long. Yeah, so the deduplicated pin tables. So now we've gotten, these are the SCSI standards that this applies to. This is the name of the table, and then this is the pinout, right? So this has been deduplicated. SCSI 2 fucks with some things, but for the most part, it's, kosher. And then we also have a different breakdown of the tables that have been pivoted here. So what we have here is, this is the IDC 50 connector. These are the signaling standards that travel over, and these are the appropriate SCSI standards that actually make use of that on that signaling standard, right? Oh, Annie. I'm sorry, I have a cat who wants to be a bug. Yeah, the librarian of old SCSI. And then what we've gotten is we've actually got connector sources for most of the connectors. The big problem at the moment is the SCA2 connectors. They don't make 80 pin variants of SCA2 connectors anymore. Everything's moved over to SAS. These other connectors are still used for other things, and they've been enshrined in standards for like via and rack enclosures and that kind of stuff. So these are all still made. It's the SCA connectors that we have a problem with. But we have all the pinouts. Sorry for obliterating your bit right there. Yeah. Okay, so the general idea is we're just gonna kind of go along and bap at these, right? Yes, we have mechanical drawings. Oh. Thank you for the gift sub, Vester. But yeah, we have mechanical drawings for all the connectors. That's not a problem. Like, let me... Oh god, where... This is probably gonna be bad. Do I not have, are there no, did my ocular sessions get trashed? Oh, god damn it. 1 second. I'm gonna have to do some document shuffling here. Ocular. Something happened when I rebooted. My X authority file got fucked, and that made session restore broken on my stuff. So I'm trying to have a broken PDF reader now. You forgot all of my PDFs. Where? All right. So it's basically all of these, but now that's not what I wanted. All right, what I actually want is, oop, I don't want to show you my home folder. Documents. That's downloads. Sorry, I am incredibly disorganized at the moment. Come on. PDF, SCSI, what have we got? So this is the SCSI Architecture Model 6. We don't actually want that. Yeah. What we want is to open Ocular again. You forgot all of my PDFs. That's understandable. So what we want is, I'm gonna pin you to the top for a second. We want these two, we want this one, we want these ones. 2R10, 2R10L, 2R10B, that's an old one. We want this one. Actually, no, I think. So we've got SCSI 1, SCSI 2, SCSI 3, 1, SCSI 3, 2, SCSI 3, 3, SCSI 3, 4, and SCSI 5, 3, 5. Okay. All right. So that's all of those standards. Yeah. Speaking of mechanical drawings, I was just on this page in the standard. We have all the mechanical drawings for these. Well, most of the mechanical drawings. The SCA connector is probably the one we don't actually have a mechanical drawing for. Jaja! Wow, hi! Thank you for the raid! 16 people! Just in time, we've just started and I've had KDE sessions shenanigans, so I just had to open all of my tabs again. But yeah, so shields up. Yeah, so the plan is then to go through and do all of this stuff. But yeah, hi, thank you, Raiders. Nice to see everybody. 64, not 16? 64? What? I thought that was 16. Oh my god, I'm so tired. I'm sorry. Wow, thank you. Jesus. Oh god, today is not my day. Why did I decide to stream today? Oh, jeez. Okay. So yeah, so the idea today, the plan, the big plan, pending all hangups, is to at least get the schematic start of this done. Yeah. Right. Okay, so Wifey did MSE 68, but only for the HD connector. We still have to do the VHDCI as well as the HD50 and all of those. So, Annie, get your tail out of my water. Thank you. Cats. Why are cats? Oh my god. Annie, please. I wish I could show you Annie. She is being adorable. She's being a pain in the butt, but she's being adorable. Right, okay. So what we want to do is open a project. We want squishy, squishy, squishy. Where's squishy? There's squishy. Squishy hardware. What is SCSI? What's going on here? So what's going on here is we are building connector adapter boards for Squishy, which is a larger project for a SCSI interface. SCSI stands for Small Computer Systems Interface. It is a... Ow, Annie, stop biting me. It is a communication standard that was developed in the 80s and is still in use today. There's a few different variations of it. I'm dealing with parallel SCSI, so think of the big Centronics printer ports and that kind of stuff. That's gone through several revisions. And Annie, you've got to move. She's trying to attack me. She wants to play. I'm sorry. That's gone through several revisions, but SCSI as a protocol has stuck around. Yeah, so everything in storage is still SCSI, at least on a protocol level, if not an electrical level. So there's SAS, which you may have heard of, which is serial attached SCSI. So it's essentially SCSI, but serial, not parallel, right? And then there's USB mass storage. That's for its bulk data transfer level. There is, that uses SCSI under the hood. There's iSCSI. SCSI is still used everywhere, right? But parallel SCSI, not so much. It's the big ones that play Squishy as a... Oh god, no. Squishy as a service. I don't know how you would have Squishy as a service, because Squishy is a piece of hardware. But yeah, the general idea is... actually, let me open Squishy. Let me open Squishy, 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 Squishy. And I will show the people's... I will show the Squishy. Right. So then, this is the main unit for Squishy. So Squishy's broken up into three parts. We have the main unit, which is the control interface and all of the higher level protocol stuff, right? So we've got Squishy over here, does DC or USB PD, right? Why is USB so... yeah. Oh, hi! Thank you for the follow! So we've got Squishy, and then this goes off to a board-to-board connector here. This board-to-board connector is the PHY. So parallel SCSI has... Oh yeah, of course. I don't think there's a bang Squishy command, but I can throw a link over to the Squishy project. There might be a exclamation point Squishy command. Yeah, there's a... You gotta have it, right? Is there not a Squishy command? I have no idea. But yeah, so all of the protocol and heavy lifting goes on inside the FPGA here, and we do USB 3 out. And then this goes over to the PHYs. So SCSI has multiple electrical protocols. There's LVD, HVD, and SE. So and it gets complicated with LVD because there's also LVD MSE, which is sort of like a pseudo single-ended kind of interface. But basically, there's differential SCSI and single-ended SCSI. Differential SCSI is either 5-volt differential, which is equivalent to RS-485 signaling, or low-voltage differential, which is MLVDS signaling. And then we have single-ended SCSI, which is essentially take the negative rails on HVD and keep those, chop the other ones off, turn them into grounds. So it's all active low, right? And so that plugs into here. And then the general idea is, it's not in this document. It should have been I should have kept it in this document, but Squishy is broken up into 3 parts, as I said, and they all nest in sort of a board sandwich. So the idea is you can interchange the electrical protocol level, but also interchange the connector, right? And there's a lot of different connectors that were used for a whole bunch of different things, as we see here. This is the quote-unquote definitive standardized SCSI pinout source. But there's IDC connectors, which you're familiar with. There's the Centronics 50-pin connectors, which are like printer connectors. And then there's the high-density 50-pin, high-density 68-pin, and then the very high-density VHD. It's either DCI or DIC. I can never remember, but it's another connector, and they all apply to different signaling levels. So the idea is, people have so much pain in SCSI with like adapters and termination and stuff, and the idea for Squishy is partially to make that easier. So you can just unplug one of the connector adapters and plug in a different connector adapter. You don't actually need to shuffle for the endless dongles that SCSI used to need. There's a funny note there, actually. So SCSI 2 is a, was it SCSI 2? Yeah, SCSI 2 is a huge problem child. And I think SCSI 2 is primarily where people run into issues with SCSI not working for some mysterious reason. Because for the most part, SCSI is entirely backwards compatible. However, SCSI 2 went and had to be a problem child. Its 68-pin high density is different. Right? The pinout's different. They switched to signal and ground lines. Right? So that causes things to break. Yes. Very high detective chief inspector. But point is, I'm pretty sure that the SCSI 2 madness is partially at fault, at least on the 68-pin variant, for some of the weirdness. SCSI, the first revision of SCSI 3, so SPI 1, which is the SCSI Parallel Interface 1, they introduced something weird, which is an AB cable system for a 32-bit wide SCSI bus. I don't know of anything that actually used it outside of maybe the IBM AS400 or some of the eServer series. Basically, IBM Kit was the only stuff that used the dual stuff, right? And then we go back, and LVD wasn't introduced until the second revision of SCSI 3, which is pretty nifty. I don't know how many people know that. Yes, I need an AS400 for testing this. Anyway, so the general idea is we plowed through all the standards, extracted all the pinout tables for every connector. We then categorized and correlated them into a final table ID to extract all of the shared SCSI. SCSI is 50-pin or 68-pin or 80-pin. There are no 25-pin SCSI connectors. I'm ignoring the Mac and the future domain SCSI stuff because those aren't standardized. And if they're not standardized, they don't exist. But yeah, so we correlated all of this data, right? Correlate all the things. So what we now have to do is go through and wire all of these up to the appropriate connectors. So we found sources. I've explained this like 3 times. We found sources for most of the connectors except the SCA2 connector, but the SCA2 connector is weird and I don't think we need it right now. Yes, Mac does not exist. I think Amiga used the future domain SCSI controller pinout. I don't know, I haven't looked into that. The DB25 SCSI, not standardized, so I'm not worrying about it. Also, that connector is absolutely garbage for SI. People are wondering why all their stuff has terrible throughput, and because it's an SI nightmare. What else is going to happen when you get rid of literally all of the grounds for the signal return lines? Yeah, IBM, as far as I know, IBM made architecture emulator cards for all of their mainframes up into including the Z14 that you can put in a PC. Not that kind of SI. Anyway, so the plan is, right now we're just going to go through all of the connectors. Yes. We're going to go through all of the schematics for the connectors. I wouldn't count the AS400 as a mainframe. It's mainframe-esque. Yeah, mainframe-esque. It's a sparkling mainframe. Right, open project. So, right. All right, we'll go to squishy connector modules. So these are all the connector modules we've got to do. This one is mostly done because wife did that and we've kind of leached most of the work. So I guess we're just gonna go through this from top to bottom and just do the assignments and all of that fun stuff. So the connector pinouts should be already sorted, but I do need to assign the footprints. I have to remember where the NOR comp, what was it, 112? 122? What was that connector again? I was just looking at it. 11250, yeah. I swear I have that connector in here. Why? Why is my connector library? It's in here somewhere. Pardon me while I struggle through finding a connector. Is it MISC? No. There's only like two libraries it could be in. Where is it? Oh god, I need to organize my libraries better. Commodore PET is a micro mainframe? No. Not even. Yeah, it's got to be in the connector library. In here somewhere. What? Alright, I guess I'm going to the original squishy board files to figure out where the absolute heck it went. Yeah, filter by pin count would probably... Yeah, no, that's not... What was I doing? KeyCap project. Squishy. This is the OG squishy. The very first revision. It's got some problems that it needs some lovin'. Ow. I'm fucking blind. Apparently. That's not right. I am Jesus, I'm blind. Okay. So that needs to change. That needs to change. But I know how to fix it, so that's fine. Close project. Alright, what I will do is I will do this. Actually no, before we do that, let us leaf. Footprint editor. Right, so we want to, this was here, this needs to change. This is now a rename footprint. I need to open the data sheet for this footprint because I need the part number. Oh, that was trippy. I need the part number. Ah, yes. The two genders, female and female. Right. Okay. So this is technically, where did it go? I lost it again. I lost the goddamn pin it. There it is. There it is. Alright. Let's just open it, because we gotta change all the properties anyway. Oop. So this is technically a 112 50. It's not specifically a 2, that can be whatever. Dip soldering. XX. Lighting, whatever, that's fine. It's fine, that's fine. This is a description. Norcomp 50 in Centronics connector. Boopity boop bop. And then this should have a 3D model. That's the wrong 3D model. Is that a 2? Do I not have the other? Do I not have the other genders? No? You sure about that? You not want to load? There are 80 genders, one for each pin. Yes, correct. Come on, KeyCAD. Yeah, okay, so you load, but you are incorrect. You are not the right gender. You are the right gender, but you don't exist. Alright, I'll go with the wrong gender for now. I'll fix it in post. That's fine. That's fine. That's fine. That's fine. These pins need to be... These pins need to be changed, though. These should be... how the fuck do you spell shield? I am such a dumbass. S-H-I-E-L-D. S-H-I-E-L-D. Shield. Why did you do that? Why did you do that? Shield. Okay. Shield. Shield. Alrighty. And then that should be copacetic. This does need to move library. How do I move this to a different library? Can I move this to a different library? Delete footprint. No. Wow, that's stupid. What I'm going to have to do is copy footprint. Trace footprint. So now it's in my connectors library. Yeah, export current footprint wouldn't move it through the libraries though. That's gonna export it as something else. Oh, hi! Where did it go? I fucking lost it again. Oh god, I'm so... Whatever, it's where it belongs now. Oh, there it is. Yeah, no, so if I do export current footprint, it wants to export it as a mod file. So I just duplicate it and then I will delete this footprint from this library. And now it is in the correct library. Okay, now back to what we were originally doing. Now, oops, boop, boop, boop. Now, that's not it. It's that one. There we go. That's correct. Where's the datasheet? There's the datasheet. Datasheet. Ta-da! Okay. That's one of the steps done. Crunch. Right. Shield. I need to be a cheeky bugger and get something. File, open project, connectors, MSE 68 HD. Wife was already working on this one, so she has all the parts already picked out. Yeah, this. These are what I wanted. And close that. And close projects. Yep. Yupsy daisies. How do I want to do this? Doesn't really matter which way it goes. Come on. Give me a ground. There we go. There we go. A micro mainframe. That's spooky. But I mean, I guess it makes sense in the grand scheme of things. Okay. All right, now we get to the fun part. This is, which one is this? Oh, that's HVD 50 CE. Okay, so we go up to here, and then we try to find HVD 50, and that's the pinout table we need. So now we have to actually find that pinout table. This document will be revised and then turned into like a proper hyperlinked thing in the squishy documentation when I get a chance. I also want to do like pretty little pinout diagrams for all of them, like like this. This is all programmatically generated too, by the way. So what I just need to do is get the SVGs for all the connectors made, and then transcribe all of the pinouts and their signal names, and then I can just generate the batch of these, and they'll all update and all that jazz. But the plan is to have documentation with all of these in it, and eventually the non-standard ones. Eventually, and yeah, it's just generated with a JSON file and this kind of ungodly Python script. But yeah, plan is to get all this documentation all happy and copacetic. And that way it's referenceable for people. Let's just go to the bottom and we'll go back up. IDC connectors use odd, even, penny. Everything else uses clockwise. Squishy is designed to be able to do both target and there's a proper term for it. It starts with an I. Initiator. Squishy's designed to be able to be both the target and the initiator. Yeah. Yeah. It's MSE. Is that connector correct? 1, 2, 2, 2, 2, 2, 2, 2, 2, 2. Yeah. That's HVD 68, SCSI 268, SC8 80, MSE 50, HVD 50. Okay. This is the table we use, I think. I'm pretty sure it was that one. So I'm just gonna put that over here. And then I go and yoink this bus. But then I also need to do all of the grounds. So let's do the grounds first. The grounds are at the top and bottom of the connector primarily. So we'll go boop. Boop there first. Boop, 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 boop. And then we have an additional ground at pin 36. Then there is an additional ground at 16 and 41. And I think that's all the grounds on this connector. Wahahaha. This pin is diff sense. So that is why it is not quite even. How do I want to go about this? I will just hang the grounds off this like earrings. That's how I'll do that. Alright, and then this bus can go down here for now. Then I'll figure out how to wrap it around. And just to fold this. Oh god, I still need to do the wiggly magic to make the keycap people happy and get this merged. DV0 plus. That's what you want. Probably actually like right there, and that means I can get you and grab you so you're like there. And then what I'll do is I'll have that there, and then we'll do this, and just kind of duplicate this, and then we will do all of the renaming as appropriate. Hopefully everybody's doing okay this weekend, however ungodly early, late afternoon it is in your relative time zone. Okay. So we've got DB0, this is DB1, this is DB2. Monday, 3:30 a.m. Rip-a-roni. 3, 4, 5. Oops, that's not what I wanted. 7. And we got parity. Or I think this was actually D parity 0 because there's 2 parity bits. Oh, public holiday, that's nice. And then this one is diff sense, which, oof, my spleen. I'm gonna do that, and I think it was just called diff sense, yeah. Found diff sense there. This pin is reserved. Because these actually both of these are reserved, which means I think we can turn those into grounds. We should be safe to turn those into grounds. This is a term power. Oop, that's not what I wanted. Fun fact, SCSI demands at least 2 amps of termination power if provided. And then this one is reserved again. So I believe that means we can also ground that. 12? Yeah, 12 was... I think we can ground these. You don't have a dot on pin 12? 12? We don't have a pin 12. And you still have the vessel? I was getting there! I'm working on it. I know I'm slow. Give me a break. ATN, and then we have ground, and then we have... No, you're fine. You're fine. Busy. Ack. Reset. wrong there. And then we have message. No, that's MSG, monosodium glutamate. And then we have select. And then we have CD. Oh. Then we have requests. And then we have IO. There we go. Ooh, tasty, tasty. Hi, hi. Yeah, 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 haha. Trying to think about how I want to branch this. What I will do. Let's do this. I will copy pasta this. I don't want this because that's turning into a ground on the other side. Paste this. Flip it. Go boop like that. 39. What is 39? 39 is reserved. 39 is reserved? Yeah, 39 is reserved. And then all of these pluses turn into minuses. Easy peasy lemon squeezy. And then the 5-volt single-ended variant of this connector is just the negative side, and the rest are ground. So, you know, nothing too problematic there. Lemon juice is good. I need to get myself a bag of citric acid. I misplaced / had an unfortunate accident with the other bag of citric acid I had. But I put that stuff in everything. Literally everything. At least drink-wise. Because if you're not getting chemical burns from your drinks, is it sour enough? I don't think so. Okay, and that's done. Well, okay, that's kind of done. Oh god, I did that too. You have to watch out. You have to watch out with that because putting granulate and especially citric acid in carbonated drinks will cause them to foam aggressively. But such is the Oh, does citric acid have a weird interaction with ADHD meds? That's gonna be unfortunate if I ever manage to get on ADHD meds. If that ever happens. Oh, I just had some water. I'm actually drinking water today. Y'all should be proud. Right, and then this is the Centronics 50. Yeah, okay. Boop, bop, bop, beep. It is normal water. But I do need to get myself some seltzer. I'm a sucker for some angry water. Oh, that's gonna piss me off. Go up, 45, over, down 45. There we go. And that is how the cookie crumbles. Oh, okay, that's one done. 1.5 billion to go. Right? If we go over here. And then we go boop. Hit PCB, boop. Oh, this connector is a big chongus. Oh no, this connector's too thick. This might be problematic. Especially because that all looks to be backwards. Oh yeah. Yeah, that's... So that's fine. But... that's pain. Why is that the case? pin 49, right? That's... I but that should be... Is that pinout right? Is that pinout correct? So if we're looking at this from the bottom, pin 1 is on the right side. So if we flip it over, pin 1 will then be on the bottom left side, right? So we flip it, pin 1 goes over there. Which means this is backwards, right? This is mirrored, effectively. Ah, that's so... That's another errata for Squishy 1. That's fun. Entirely backwards. How did I get the connector backwards? How does one do that? Crappy data sheets, that's how. Yeah, because in this, the connector's facing down here. Which means if we rotate it 90 degrees, that's here. So we have to flip that over, right? I'm understanding that correctly, right? So with this current pinout, the way this is oriented, with the connector facing down, if we are looking at it from the top, then these pins need to stay on their rows, but all swap, right? So one goes over to here, right? That's how that would work. I think that's how that would work. Okay. Well, yeah, the biggest thing I hate is data sheets showing pinouts from an X-ray view through the top or from the bottom view, but never mentioning it, or it's not consistent in the vendor. Like, there are some TI parts which will do X-ray view and some which are from the bottom. I just wish you would standardize. I wish the industry as a whole would standardize on which ones to do, because I have small brain. My brain is small. Where is renumber pads? Then we just go boop, 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 boop. Boop, 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 boop. Yeah, bottom view is kind of annoying, especially when you're making a footprint. Boop, 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 boop. Okay, hey, we have renumbered. Congratulations! On Squishy, it wouldn't have been a huge problem on Rev 1 because it was all programmatic, but that does mean there was, that's still technically an errata. I don't like having errata! Why would you do this to me? Okay, that's more sensible. That's what I expected. That's copacetic. That's Daijobu. I'm not happy the connector is so fucking thick, but, you know, it is what it is. It's wider than 75 millimeters. Please, please, for the love of the old gods. Also, Tag Connect sucks, so we're using these Worth red connectors. They're pretty nifty. And the new? And the new? Yeah, red fit. That's what they're called. The red fit connectors. Using those. Thank you. The new gods? Yeah. I don't know about the new gods. We haven't had a meeting yet. Well, I'm glad someone loves them. I haven't used them yet. Well, I will give Tag Connect credit where credit is due. It's small. That's the only credit it gets. The guy's an asshole, and they're expensive. That's the negative. The pro is they take up very little board space. All right, pending all the fucking around with the PCB that I have to do, that's that. So, are we talking about Ferris? We're talking about Ferris there, the cute crab god. Yeah. I don't know. The guy behind the Tag Connect is kind of a dickwad. So what I'm gonna do, because this is the HVD 50 pinout and it's consistent between, no, it's only consistent in the HVD case. Well, no, there are multiple of these. We also have the IDC connector variant. So what I'm going to do is I'm going to copy this, close that. So now that is in my copy buffer. Okay, we're happy. Where did? Cool, thanks. Did KeyCAD fix this yet? Oh, they did. For the longest time, you would press this, and this would come up and then it would stay there, and when you move the window you just had a stack of these. There are no notifications available. Okay, thank God they fixed that. That was kind of annoying. All right, we'll open a project, HVD 50 CE, and then we just go down the line, right? HVD 50 HD. So all that's different here is the connector. The rest of this is all the same because it's all HVD 50. I should be able to just plug it in like that. And then this is an HD 50 connector. And then the HD 50 connector is the, I think it was the amp light. This one, no, that's the 68 position connector. It was this one. I'm pretty sure it was this one. And in theory, now that we've done all of that work, that should be all we need to do there. Again, with the grabbing it by the jangly bits. Why? Grab it by the goddamn center of the footprint, KeyCAD, please. And then we go boop, 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 like that. And look at that, ain't that just a beaut? These boards are super simple, but they're kind of designed to be. Although these boards, even if they are just connector boards, they're all 6-layer impedance controlled still. So you know. That's fun. Oh, thanks. I've had the same stream soundtrack for most of my streaming. And there should be a link to a GIST which has all of the track lists. Yay! I strive to have a cozy environment that people can just kind of, you know, chill, vibe, have a good time. But yeah, that's done. That's that. We did the thing. Look at that, another connector board down. See how easy this is? This is really easy once you get the hang of it. Once you finish all the hard stuff. This one isn't shielded because it is just a, oh, this one's, no, this one's still the same. This one's the same. It's just the connector changed. Oh, hi! Thank you for the follow, Machiavellian Alloy. I think that's correct. Yeah, this should be correct. We are just an IDC 50 header. Nothing too fancy schmancy. Oops. Just put that there. Nothing too... Nothing to it, but to do it. Wiggled. Are you gonna grab it on the corner? You grabbed it on the corner. Center pin's there. Right, that's the center of the connector. Whatever. You can live like that. Damn, you live here? You live like that? That's fine. That's fine. Daijobu. There you go. And all your SCSI needs. These will need to be adjusted and laid out and all of that stuff and more finalized, but in the meantime, we're just getting all the connectors and stuff sorted. So that's that one. The next one would be the HVD 68, right? Which means for the most part, our existing copy pasta will work. However, we will need to adjust it very, very slightly. We also need to fix this connector. HD68, its footprint is this one. HVD68, where are you? So HVD68 is effectively kind of squished and squabbled around a little bit. So maybe it won't necessarily be entirely the same. However, we will do our best. So we go ground from 6 down to, what was it? 30? 6 to 30 on each side. And that is the main ground span. Right, so that's 64 up to 40. And then the additional grounds would be 50. 53. 55. And 21. And then, yeah, I think those are all the grounds on that. Yeah. Yeah, that's all the grounds. So many grounds, so little time. Hi Claire, how are you doing? I can cut that. Because for the most part, I'll do that. Yoink that. Bingo bongo. Then this all should be consistent. Right. So the way the 68 pins work is the upper 8 bits and parity bit are all put on the extremities of the connector. Right? So we've got bits 12, 13, 14, 15, parity 1, and then we've got bits 8, 9, 10, 11 there. But the rest of everything is mostly the same. It has just been transmigrated. This is slightly different too because pin 19 is reserved. These two have turned term power has been doubled up effectively. So we've just kind of like stretched the connector a little bit. Like these two are now term power. And this one is attention. Where did attention go? Uh-oh. 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 Oopsie doopsies? Oopsie poopsies? Yeah, where did attention go? Oh, it's there. Attention's on that one. I have to check all of our 50 pins again. 50 pin HD. Attention's there. And then IDC was the last one. Attention's there. I might have just accidentally did it then. I accidentally did the attention. Okay, that's fine. Okay, stretch. Oh, did you hear that? That was my back. Okay. Stretched. I have been crunchy like this my entire life. Stories from when I was just small. Stories from when I was just a kitten have been made to me that I have always been a crunchy disaster. Alarmingly so. Yep, crunchy aki. Okay. So that is that half of the connector. That is the same. And now we just have to do splicing on this half. And then term power is again doubled up here. Just do that, flip that around. And then I think for the most part, just grab these. Yeah, okay. Boop. I mean, if someone wants to do it, I won't say no. Although I am not big enough or popular enough or cute enough or anything to have any fan art done of me. I don't think, I think there's like one artist who follows what I do. I'm not upset about it. I'm just observant, as it were. There we go. Okay, but my content is incredibly niche. This is not traditional VTuber content. And I'm not even the biggest VTuber in this space who makes content like this, so I am a little bit of an underdog, as it were. An undercat? This is 12. 13. 14. Well then, spread the word. 15. And this is parity 1. And then these go like that. And now they are minus. Aw, that's very kind of you. I think that's copacetic. I think that's copacetic. Copacetic is such a fun word. Why don't we use it more often? The world has forgotten about copacetic. They're sleeping on this. All these Gen Zers and Gen Alpha-ers sleeping on it. This is 9, 10, 11. I should have probably zero padded these. That way the labels all line up, and that would have satisfied my... Oh. 8, 9, 10, 11. I'm a dumbass. 9, 10, 11. Oh, music? Where'd you go? Can't bend it into a new word. Then they're just not imaginative. Oh, hi, thank you for the follow. Dorothea? I think that's how you say that. Zaritha? The words are hard. I apologize for butchering your name. It is monster time now, though. I have finished all of my water. I've been a good girl. I drank a cup of water. A whole 16 ounces. Or 473 milliliters. Oh no! It's in my nose. Oh god. Don't get monster up your nose. I don't advise it. Oh, that burns. Look, I can only fit 470 some milliliters in my cup. And I only know that's the reason because I can fit exactly 1 can of Monster up to the brim in my cup, which is exactly 16 ounces. Oh, hi, thank you for following. Tech Witch Oki. Tech with Oki. Witch, I'm sorry. With. Words are hard. Tongue is tied. Baba is you. An imperial oh my god. I need to get graduated cylinders and beakers to use as cups. Those are all metric. Yeah, okay. So I think that is done then. Which means we switch over to the pissabib. The pissabib? The pissabib. There we go. yes, I have, Rhea. It's always nice to have people around. There we go. Isn't that just... Oh, mwah. That is the way. That is the way. That's a little close to the edge, yeah. I have a, these footprints have a guideline of where the PCB edge needs to be. So, cause these connectors slightly overhang. You can see the very slight overhang here. But yeah, okay, that looks good. I need to go through all of these connectors and fix their colors. But it's looking pretty good. It's looking pretty good, yeah. I think that is all of high voltage differential connectors. I think we're done with that. Oh, hey, Realty! Wow, 21 months in a row. Ain't you going? I hope you're doing well. Feeling better after events. No. We have one more 68 pin, which means I need to go back into here. No, that's not what I wanted. No, go back. I wanted the schematic. No. You wanted the schematic. Why did you not click on it? Okay, there we go. Copy that because I don't want to have to redo all of that work. And now we can open projects. This one. Boop. Like a glove. Deselect that line. You accursed tool. This is VHDCI. And this is a terrible, terrible connector. This one. It is this monstrosity of a connector. It's actually not that terrible of a connector, it's just small, compact. There's 68 pins stuffed into here, and the pitch is... Look at the pitch between... Oh god, this is just... I don't even know how we're gonna route this in this connector. It makes me anxious. Even on a 6-layer board, it's going to be just absolute heck. But yeah, there's that connector. Yeah. That is cute. That connector's just a little, I think it's a little skinnier than the mezzanine connector there. Adorable. He's adorable! Adorable. Okay. I'm sorry my ADHD is apparently really bad right now. I have literally all the brainworms. All of them. Just all of them. Okay. So we did that. We did the thing. Let's actually commit this. Commit it? Commit it where? Probably to an insane asylum. I don't know what I'm talking about. I'm sorry. I hope you're all entertained. Squishy connectors. Ba-do-ba-do-ba-do. Hooked up. HD 50 CE connector. Ba-do-ba-do-ba. CE. CE. Wah wah. Okay. Boop. 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 And then this is the HD50 HD connector, and this is the HD50 IDC connector. I am babbling like an insane person. I'm sorry. VHDCI connector. Boopity boop pop pop push. I'm sorry? Hello? Why? Why? Hi. Hit push. That was so weird. Okay. Yeah. Yeah, that was entirely bizarre. Why was I getting ignored by GitHub? No, that shouldn't have been a gnome keyring fuck up. Shouldn't have been, because I don't use gnome keyring. I hope it wasn't. The KDE wallet stuff? No, I don't use that either. Well, okay, I do, but my SSH key is not in my KDE wallet. I sign all my commits, but my GPG agent's still chuchin, so I don't know what that was about. I was just getting connection refused from the GitHub. Bizarro. Isn't that Codeberg? Wasn't the Codeberg April Fool's thing GitHub for lesbians? I'm pretty sure Codeberg's April Fool's prank was the GitHub for lesbians. Which, you know, I can get behind. Alright, what were we doing? What was I doing? Right, open projects. Connect to modules. Alright, we did all those. Let's get this one out of the way because this one is a huge pain in the ass. We don't have the footprint for it. So I'm just going to do the schematic capture side. So... I mean, hosting Git at home is easy. You just have to initialize a bare Git repo on somewhere with SSH access and you can push to it. Oh, hey! I'm so sorry. I have, God, what is my moderation stuff set up for? I'm so sorry. I've been cautious about, hate raids and stuff, so I have it cranked up pretty high. I apologize. Jesus. Oh, God. I completely forgot. Actually, we can't even do this one yet. We don't have some of these signals. So this connector we are missing specifically. We are missing 12 volts, 3.3 volts, mated, spindle, LED, RMT, DLYD, and all 4 SCSI address bits. We cannot do this connector yet. And that's fine. I'm okay with that. Sorry. Zarithia. Okay. Hi! Welcome! Yeah, hi, welcome. Sorry about that. Yeah. Yeah, we can't do this one yet. That's okay. That's fine. So I guess we're on to the last little stretch then. Connector modules. So MSE68HD was already done by wife. So she already has this all. Right. This is different because the grounds moved. Because fucking pronouns. Because reasons. Oh, right. The LVD and MSE stuff changed. God damn it. That's okay. We all have no idea what we're doing initially. You gotta start somewhere. Yeah, the grounds are all fucked because, this is annoying. I also am not entirely a fan of how she laid this out. But for prosperity? Words? For words. For reasons. Reasons and words. I'm just gonna copy this. Yeah. Why are these marked? These are 53 reserved. Was I not supposed to turn the reserved into ground? I don't actually know. Start bapping and brain does all the work. Making PCBs is actually not that hard. Well, no, there's a note in the, there should be a note in here somewhere. Descends. That's grounded in single-ended. Ground in SCSI 2. It's SC8. Oh, right. SCSI 2 is being a weirdo. Grounded SCSI 1. SCSI 2 makes these reserved. This one SCSI 2 makes signal reds, which is entirely equivalent. I think grounding those was fine. I think that's Daijobu. I'm going to assume that's Daijobu. Buzz buzz. Buzz buzz. What about modular synths? Oh, what Freya was saying. Okay. Sorry, I'm entirely tuned out. Okay. We're good. Okay. Alright. Open project. VH DC CDI. VH CDI? DCI? DCI. D's nuts. Right. Okay. I'm going to slightly change this out because I do not like how wifey did this. Go here, go here. On the note of needing help with PCB stuff though, I am more than happy to help people if they want to. I don't know what I'm doing, but in the events that I do, I am happy to help. So you just gotta poke me. I have been told I am approachable. I do not know if that is true. Yeah, that's one of my big worries is oh, squishily so, thank you. One of my big worries is that people find me intimidating when I am very not. I try not to be. Give me the god damn it, KeyCAD, please, for the love of God. It's pretty much just on the data sheets, but then if you're doing things with the data sheet will tell you for the most part, unless you're doing RF stuff, in which case good luck with that. No, in general you want 50 ohm impedance. Impedance has to do with like the imaginary component with reactance and resistance and capacitance all on this. It's complicated. Stick with 50 ohm, you'll normally be fine. Right. Champ. This connector is the champ. Going to move this to somewhere. Here. Hi. Yes. Come on, SCSI. That is fine. Is fine. That is Daijobu. Daijobu even. Yes. Indeed. Right. Righto. Got that. And then we want to go to here. Import. Okay. Boop. Flip that around. Tasty spaghetti. Boop. I've got some truly cursed high-speed schematic stuff going on in some other projects too. It is great. Like, let me hunt for a project real quick here. There it is. So this is effectively a 8 gigahertz sampling oscilloscope. I modified the schematic a little bit from the original source material. It's dealing with weird Peckle things, so that's why there are these weird resistances. I wanted to add a front end onto it for a high impedance path that also gives you higher voltage inputs. But the problem is I can't find an input buffer that will preserve the 8 gigahertz bandwidth. Which is problematic. And some of these things need to change. Like there's the sample latch clocking, which is using a few 7400 series logic. And then there is the actual latch delay offset compensation, which we could probably cascade 2 of these to find a larger delay, but it's still pretty slow. And then because it's all temperature dependent, instead of using an actual temperature sensor, we're taking the cascaded output and using that compared against the voltage reference to say how skewed things are, right? And then it does some weird Peckle clocking garbage. And then you go into here. This is probably wrong because you have a global trigger and then the channel trigger. And then you can do an inverting buffer to then actually latch that into a D flip-flop. And that comes out from this front-end comparator. So you have the VREF. And what you do is you essentially sweep the VREF from bottom to top range. And then take comparator samples from that. And then you offset the trigger time so you can sweep. So you're essentially sweeping in X and Y. And that's why sampling oscilloscopes only work on repetitive signals, because if the signal's not repetitive, the sampling won't work. Oh, yeah. Electronics is pretty fun, and I'm convinced that anybody can get into it. That unless you're dealing with the deep black magics of high-speed signal stuff or weird signaling integrity levels or RF, it's pretty dead simple for the most part. Once you have a little bit of background information on it. But even then, you don't need to learn everything, right? Simulate it? Should be able to simulate most things. Yeah, you can simulate most things too with Spice. Okay, this is done. This one is done. And then I think MSE 50 is just the MSE 68, but truncated. I don't actually know that. We'll have to see. Why not? RF is the funnest. Don't you love etching sigils into precious metals to make invisible energies do your bidding? That's all RF is. Basic witchcraft, everyone knows that. And if you think I'm joking and you don't know RF, just look up like Rotman lenses. That's R-O-T-T, Rotman lenses. So fucked. Just so incredibly fucked. Open project. That one is the one we already did, so now we just have these 3, so I'll just go up to CE here. Deploy it. Yeah, and then, oh god, board cavities and it's just pain. It's pain and suffering and pain. I wanted that one. More comp. Hello. Yes. And then you are MSE 50. 50, 50, 50. Bitty, 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 boo. Dippity, bida, papa. Right, yeah, Daijobu. 68. Let me see. Where did it go? Where did MSE 50 go? I'm on the wrong screen? Okay, no, here we go. All right. It's specifically it's for frequency shifted arrays. Instead of the normal phased array stuff, it's absolutely nuts. DB0 I think is the top one there, right? Centronics 50. But yeah, I don't do all hardware stuff. I do a lot of gateware, so FPGA programming. I do some ASIC stuff, so actually making microchips, and then I do low-level software and higher level. I have my grubby little paws on the entire computer stack from software to silicon. It's not great. Or it's incredibly great. It depends on who you ask, I guess. The point is, I know how the sausage is made very, very deeply, and that is why I don't like computers. Right. Why are computers indeed? I'm talking to myself at this point. I deeply apologize. I'm more entertaining myself than y'all. Oh yeah, that's the thing. I was actually talking about this in the Discord earlier today. I don't think there's anyone who's actually competent in electronics. Centronics. Yeah, I fucked that spelling up. I don't think there's anyone who's actually at Trongle. Yeah, say Trongle energy there. Centronics 50. Spelling is hard, okay? Oh, I love my computer too. It's just I don't know how to explain the love versus don't like computers kind of thing, right? Like, computers are great until they aren't. Yeah, it's a love-hate relationship. But the big problem is all of these quote-unquote tech influencers and tech bro types who unabashedly love, quote-unquote, love technology and are interested in technology and that just goon all over it. Oh god, I can't stand that type of person, honestly. It's like, yeah, you can have whatever you want to do, all your happy and likes, but keep your smart home gadgets away from me, please. I don't need my washing machine to email my dryer that it's done. You know? Who needs that? What? We need to stop putting computers in things. It is too much. Alright, okay, so this is mostly done, but we need to... Oh, yeah, that stuff is like MQ... Well, I mean, internally it's probably MQTT. Or something like that. I don't need my... The point is, smart home appliances absolutely suck eggs and need to go away. Alright, so diff sense is 11, that's fine. This then turns into... here. So these are reserved, but they're marked as grounds in the other SCSIs, so they stay there. And then 13 are... no, that's... reserved. 13 is explicitly a no connect for some reason. And then that's ground. Like that. yeah, that's what got this whole conversation started, is when you posted that image. That was wild. 37 is also reserved, so I'm just gonna make that a ground. 35 is a ground, 36 is a ground, 37 is a ground. 38 is turn power, 39 is reserved, but it's also a ground. Okay. I think that's right. So DB 0, 1, 2, 3, 4, 5, 6, 7, DP 0, ATN busy EC, RST, MSG, cell CD, rec IO. Yeah, okay. I think that's good. Yeah, if I ever had any... Oh, okay. So, for those who weren't here, I am working on a project called Squishy, which is a parallel SCSI appliance, basically. Let me open up the main board. And if Freya wants to post the Squishy link again for those interested, that would be appreciated. Yes, quite. Open projects, Squishy, main unit. So Squishy is essentially a SCSI multi-tool, as I like to call it, right? It is designed to talk every single parallel SCSI interface, protocol, electrical-y thing. And it's designed to be both an initiator... It's designed to be both an initiator and a target, so it can act as something that's talking to other SCSI devices, as well as something that is a SCSI device. So a lot of people know the big names in quote-unquote SCSI emulation. There's the Pi SCSI, or the Raw SCSI. There is the Zulu SCSI, SCSI to SD, Blue SCSI. Those are all primarily storage emulations, and they are all primarily target devices, right? It's a lot of like the vintage Mac scene, replace your SCSI hard disk with yada 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 yada, right? The boring stuff. And they all only really talk SCSI 1 or 2 or 3, but they talk the low speed 10 megabit SCSI. Squishy is explicitly designed to talk SCSI 1, SCSI 2, SPI 1, 2, 3, 4, 5. It's also designed to talk HVD, LVD, and single-ended, as well as all the way up to Ultra 320 SCSI, so that's the 320 megabit a second standard. We might be able to hit Ultra 640 if we press our luck on the Silicon Lottery a bit, but the general idea is Squishy is designed to be the be-all and end-all of SCSI interfaces. Right? It's not designed to be a storage emulator, even though you could be. It's way too overbuilt to be like a hard drive emulator, because it'll do things like it can pretend to be an initiation system to clone drives. It can pretend to be anything you want. It can do weird things like Linux pass-through, because we have USB 3.0 here. This can pretend to be a SCSI hard drive and then mount itself to your Linux box, or you can have it interface with something that is a SCSI hard drive and mount it with a fused file system and talk to it just like that. There is an SD card for if you ever want to do like storage emulation stuff, but it's not really designed for that. It's more designed as an appliance. That's why it has like this SMA trigger port. So if you're debugging a particularly nasty SCSI bus, you can like have this send a trigger signal so your oscilloscope can trigger off of it, and it can do bus capture, or it can take trigger signals, and it has half a gig of onboard RAM effectively, and it's kind of overbuilt for what it is. But it's designed to support almost all of the corners of every single SCSI standard out there, right? If that makes sense. As such, it's kind of complicated, but it's made up of 3 parts. There's the main unit here. There is then the electrical interface boards, which are the PHYs. So SCSI has LVD, HVD, and single-ended. HVD is RS-485 signaling, LVD is MLVDS signaling, single-ended is essentially the bottom half of the RS-485 signaling, and then there's also MSE, which is a whole different thing, but that's kind of tied in with LVDS, the LVD in a way. But those are separate boards that plug into SCSI via this Squishy via this connector here. So it turns these high-speed interface signals into like the LVD bus or whatever, right? And so SCSI's kind of modular, so you don't need like a bunch of adapter cables or anything like that. You can just kind of unplug parts and replug parts back in, if that makes any sense, right? So then working on the like the PHY module, we were working on the LVD PHY. This is one of the big PHYs that we need to get done. And it's designed to take in all of that and turn it into an LVD stream. So we have our input, we have our output, and we have the appropriate driver blocks for the LVD signal. And this includes capacitively coupled preemphasis drivers. Yeah, that is one nice thing of Blue SCSI, but Squishy is not really designed to be entirely standalone. It never was from the beginning. As far as I'm concerned, Blue SCSI, Raw SCSI, etc. all occupy different... those are all in a different niche. Squishy is more geared towards like archivists and the more advanced retro stuff. It's not geared towards people that are primarily into like, you know, vintage Macs and that kind of stuff. If VAX systems, yeah, like mini computers, not microcomputers, right? That kind of thing. This is bugging me. Oop. There we go. Right. So Squishy is kind of overbuilt. Like it's designed to provide 2 amps of termination power current and just... yeah, and it's supposed to be able to talk to every SCSI device under the sun. So it's kind of like software-defined SCSI. You can turn it into whatever you want. It's primarily like a FPGA-based gateware system. There's no general source code for it, so it is a little more complicated. However, that complication does mean that you're a lot closer to the metal, right? If that makes any sense? Sorry, I like to get rambly, apparently, about that stuff. My connector is still too goddamn big. Something autistic rambling. I apologize. But yeah, so... yeah, it's all done in Tori, which is a fork of Amaranth, which is a Python-based DSL for gateware. So it's all very tightly integrated. And that kind of fun stuff. Yeah. You say don't apologize, but you have to realize that my self-worth is literally in the negatives, so I feel like I need to apologize for everything I do. I can't help it. It bothers my wife too. It's just that I can't do anything about it. It's like second nature. Yeah. Yeah. Yeah, I feel that, don't apologize. I'm sorry. Stop apologizing for apologizing. I'm sorry. Yeah, it's a bad loop. I get into that too. I know the feels. That wasn't the right connector, was it? Yeah, no, that wasn't the right connector. That's the right connector. Again, with the grabbing it from the corner. Nope. There you go. Yeah. Okay. Look at that. Ain't that cozy looking? Yeah. Hi, Joe. Anyway, what was the original topic? Electronics? I think it was about electronics. Yeah. Yeah, learning electronics is easy. Well, doable. It's very doable and actually more accessible now than it used to be. Yeah. Cozy. I try. Connect modules. I think this is the... No, we still have the SCSI 268 HD. That's the last one. But we are actually very nearly done. Well, we were very nearly done hooking up the schematic until we hit the other parts. But this is the big oofs. Big oof, as they say, as the kids say. I don't know what I'm talking about. I have no idea. Oh, don't worry, I've got the anxiety disorder stuff too. Yeah, I vibe that. Yeah, I don't think I don't do game. I am weird amongst even my friend group. I don't really do games. I'm just not interested. Like, I'm not super interested in them. You know, it's weird. Maybe that's just my brain being dumb. Oh. Just go center. Close enough for government work. Yeah, that's fair, that's fair. Yeah, all PCB routing is Factorio. But instead of, like, green science, it's electrons. Yeah, or Shenzhen.io, but on hard mode. Yeah, exactly. It's going to be fun doing all the routing because this all has to be impedance controlled, length, and skew matched, which is annoying. I don't know, Freya. I will let you know as soon as I find it. What's I doing? What are we doing? What are we doing? What are we doing? Right. Code project. I think we can commit some stuff now. This one we can reset. That doesn't matter. MSC 50 CE. Ah, CE, yeah. Ba, 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 da, da. IDC. Yeah, gotta love the speed spaghetti. Speedy spaghettis. It's a little painful when you get into the math. You want forbidden spaghetti? I have some forbidden spaghetti sitting on the desk next to me. It's like 400 feet of LC fiber. That's some forbidden spaghetti right there. Are you gonna push, or are you gonna give me that weird error? Yeah, you pushed this time. Cool, thanks. Also, yeah, ignore these notes. I was taking notes on the EEPROM, the EEPROM format, and where the header is meow. The magic bytes for the EEPROMs are meow. But yeah. Also, did you know it's incredibly annoying to get very small EEPROMs or flash chips? They're all huge, like a kilobyte or more. I just need like bits. I need bits. Yeah, high fiber spaghetti, exactly. Yeah, EPROMs, exactly. Putting nyan ever. Yes, that's how it's law, it's required. You're contractually obligated to put nyan in everything. I don't make the rules. Just bang it in part of it. But I can't. These EPROMs are explicitly on the PHY and the connector boards, so Squishy knows not to blow the ever-living bejeebus out of whatever it's connected to. That sounded a lot worse than it is. Techubus? Oh, that's really good. Techubus. I approve. That is very, very, very good. Okay, now I actually have to do math. Do math? What the fuck am I talking about? No, it was this SCSI 2. Yeah, okay, that's only the HD connector. That's all I needed to know about that. Yes, it is time to do math. What am I talking about? Oh, I forgot to get the capacitor. I forgot to keep the capacitor with me. I'll just rip it out of here. I wanted the schematic, not the PCB, thank you. Yeah, but these are the wiggles that you need. These are the ones wifey did. These are all nice and impedance matched and skew matched and all happy and kosher. And, well, technically, because we are still under, like, 800 megahertz, and the speed of light in copper isn't that fast, our skew is negligible, I am still just anxious about all of that, so. For anyone who wants to consult the math. We're looking at an average propagation speed of 6.5 picoseconds per millimeter in copper. So if we don't want to blow the skew budget, so we have technically 13 millimeters of wiggle room, but I would prefer to keep that, you know, low. And this is also, again, it's assuming that 1 gigahertz frequency, so this is probably up in order of like the second harmonic for the SCSI stuff. If I really wanted to be annoying about it, I'd go all the way up to the 13th harmonic and make sure we're matched up there, but, you know, it is what it is. This is entirely hobbyist. I am a software engineer by trade. Except I'm a NEET, so I don't know if I can say by trade. Because I'm not in a trade. I don't have a job. By training, I guess. Oh, hi Esden! Thank you! You'll be happy to know I have entirely trashed my sleep schedule again. No, I'm working on fixing that. No, what happened last night? Gossip, what happened? You can just DM me it. Oh no! What happened? How? Oh god, that's tragic. Oh my god. Do we know? I think that was in a shared complex? Oh no. Ah, that sucks. I'm so sorry. Oh my god, that's... What kind of irony is that? I'm sorry, that... Yeah, oh... I hope there was fire insurance. Oh, yeah. Oh, I'm sorry. That sucks. That's so bad. Yeah. That's another thing to throw on the pile of stuff to deal with. I'm sorry. Yeah, big hugs. I need to bitch at Rachel. Uh-oh. That's not right. Yeah, really. Oof. Yay. Eek. 12 is ground. That can't be right. That. Oops. That's not what I wanted. Yeah, I will make sure to have a page keep a eye out on that. Yeah. Oh gosh. That is so devastating. I'm sorry. Yeah, thanks for the update. That's unfortunate to say the least, but it is what it is. I should be good to go tomorrow. I've been adjusting my sleep schedule so it is appropriately skewed. And plus I owe you, I don't know, how many Glasgows are left? I still owe you like 700 Glasgows. I will still need a ride. The car people didn't get back to me Friday. They didn't call, and they're closed on the weekend. So it'll either be done Monday morning or Monday evening, and I'm betting it's done Monday evening. I hope nothing exploded Friday, and they didn't run into anything problematic, because ouch, expensive already. But I should have my car back Tuesday, ideally. I need to call them. Anyway. Right. Table 5, table 5, table 3. Or table 5 and table 3. Yeah, fingers crossed. Right. I want SCSI to table 3. What? That's not right. We're missing half the connector. Oh, I know. I'm angry. I know what happened here. So, this is the expansion connector. So this is the primary data bus. This is the expansion bus. That's why it's different. Come here. All right, nothing in here is fucking. Nothing in here is hyperlinked. Too many table. This document, this text document is just full of so many tables, and it's like 2,000 lines long. It's almost it's 500 short, but it's so many tables. Just so many tables. Yeah, so many tables of tables. I had to do manual table pivoting and just ugh. Sorry for absolutely destroying the bitrate, by the way. Yeah. Scroll. Alright, here are the connectors. I guess. Yeah, another project to do my... Oh, don't even... I am just on... the yak stack is real. I tell you, the yak stack is real. Actually, you might be interested in this because the Blackmagic probes connector images are all generated off of discrete Python scripts, right? And I was working on the same kind of thing for Squishy, but what happened is I generalized it into just a set of JSON files that are then imported from a singular script, kind of unifying it, and then it can automatically spit out the diagram. So I did do a mini project in a project, which is this accursed Python script. But yeah, so that's fun. What was I doing? Right. Okay, tables. Tables of tables. Yeah, I think I have a branch on my local fork of BMD where I was hacking it together and testing it out. I never got it fully fleshed out because of other things, but I can... But what about Rust? Now it's fine. Rust is welcome here. Rust is a cozy language. Right. Right, this is the B cable. The B cable is all of the extra signals. Yes, the crab was mentioned. Alright, so we can't do this one either. Yeah, it needs some work. It's not great at the moment, but it kind of works. PM. It was really only designed for my specific needs in Squishy, so it would need to be adapted for BMD, but it should work. Yeah, okay, I think actually that means we're done. Because the SCSI 268 pin stuff is entirely fucked too. Well, okay, I should clarify, we don't have the signals for that on our board. Because our mezzanine connector is only 100 pins. If we want to do this, we need to switch mezzanine connectors, which means we need at least 200 pins. That is semi-problematic. So I'm not going to do that. So we're done. Yeah. So we're done with that. I do want to look at what Wifey did with the netclass stuff here because I want to set that up on the other boards as well. That's going to be kind of painful. So I will just get this duplicated. But that's not fast enough! Multiplexers are too slow! Wiggle it harder. No, the problem is it's already wiggling really hard. You're technically overclocking the ECP5 to get 160 megahertz out of its pins. Even though they're only rated for 150-ish megahertz single-ended. So, you know how it be. Alright. What is this color? I'm going to copy this color because this is good color. Is good color. A hack is a hack is a hack. Right, but I'm trying to make Squishy not a hack. That's the problem. Also, music disappeared again. Oops. Right. We can reset this. We don't have to worry about that. It goes away. Discard those changes. Now we are all kosher and copacetic. Now I have to go back through all of these and set up the net classes. I mean, there's faster FPGAs, but they're all so much more expensive too. Which is the primary problem. Oh no, all of these net classes should be set up already then? So why? These net classes are set up already. Why did this not? Okay, see ya, Freya. Oh, right, because that's... Because that needs to be con. That's not phi anymore, that's con. Okay. Alright, this is a problem I can solve with a text editor. This is a problem where I'm not going to use KiCad. I'm going to use a... Just going to use VS Code. Right. Net class patterns. Ta-da. I need to look at this one was patterns. Specify con. Okay, yeah. So it's just swapping these to con. Easy peasy lemon squeezy. It's in here somewhere. Somewhere. This would probably be faster with find and replace, wouldn't it? Alright, let's search for... Oh, that's not gonna do what we want, though. There's no specific find in subfolder. Oh, no, there is. So if I want to explicitly find phi, right? Need to expand that. I want to go into parts, squishy, connector, modules. Pro. Did I fuck that up? Oh yeah. Connector modules. There we go. And then yeah, these should all be turned into con. Okay, have fun with the drop off. And this replaces with con. And then we do the things. Do the thing. There we go. Yeah, okay. So that's copacetic now. Squishy. Oof, that's hot. Updated net class patterns. connector ports. Easy peasy. Easy peasy lemon squeezy. Oops. The next challenge is nothing here for net classes, right? That's fine. That's fine. What I want is in the PCB. Or maybe not. That's all still stored in here then. Net class. Okay, so I need to move these net settings over then. Because those should all be done. I think that's the only other part I need to adjust manually. Yeah, I think that's the only other net class stuff that needs to... Oops. Where did you come from? Go away. Ow, go! Be banished. I banish you to the nether realms. Yeah, okay. Yeah. Oh, hi, thank you for the follow. That sounds like a sponsor message, so I'm not going to read it out loud. But thanks for the follow. Yeah, so this is then updated with all of that. I will say, KiCad having its project files be plain text so I can just do this and be a little gremlin is pretty nice. You're not supposed to edit these manually, but I can, so I will. Because it's faster than opening the project, changing the settings, yada 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 yada. Yibbity yabbada, yibbity yabbity. Hope you're all doing well as well. Just having a chill time, hanging out, you know? You know? Just being generally daijobu. Oh, pat. Oh, I have never made a rice maker pancake. I have a rice maker, I should do that. I also need more rice. The grocery store over here has a shitty selection of rice. I need to find a proper Asian grocer's that has the good shit. Yeah, I just need to find a place around here. Oops, that's the wrong file. Yeah, I need to get one of those 50-pound bags of rice. That'll last me forever. Especially because I don't really eat a lot of rice recently. Can't find any! Ah! Oh, oof, pat, I'm sorry. Squishy connectors updated. SCSI net class settings. geeky way. Okay, I think that's that part of the connectors done. The hard part now. I don't know if it's the hard part. The annoying part. Non-sticky rice is bad. I mean, it all has its place, but yeah. What am I doing? What are we doing? What are we doing? What are we doing? What are we doing? This document needs to be updated. Probably. Maybe not. I don't think, maybe this document doesn't need to be updated. This part does. Right. Righto. Might be a good time to wind down now, actually. We've been going 2 hours, 20 minutes. That's not too bad. I've got a headache. Although that might just because glasses get dirty for inexplicable reasons. How is it you never touch your glasses, but they always get absolutely filthy? Drink water, but I only have Monster left. And I haven't even finished my Monster yet. Ba-da-ba-ba-ba. I'm loving it. Oh no, I've sung the forbidden theme tune. Oops. I don't even like McDonald's. McDonald's is nasty. Yeah. Yeah. Okay. What are we doing? 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 Let's open projects. Let's go through and adjust all these connectors then, so they're at least centered and have some semblance of cohesiveness. Oh god, I still don't know what I'm gonna do about this connector. It's too fat. I could honestly leave it like this, so we have these castellated holes on the edge. Would that be a bad idea? Oh, I do need to turn on the AC though. Jesus Christ, it's hot in here. How hot is it? What is the temperature? What are you doing, Annie? And I'm sorry, apparently there's someone outside and Annie does not like that. Annie is not a fan. Yeah, it's 27 degrees by my desk. I'm turning the AC on. Alright. Yeah, so what do we do? 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 So that's all routed and happy. These need to be adjusted. So these are no longer visible. Oh god, why are people noisy? Why are people thumpy and bangy? I don't like people. Okay. Boop, 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 boop. Just like that. Oh god, they're loud. loud too? Why are they loud? I can hear you from inside. People, please. I just want to have a nice, quiet little time, you know? Just chilling. Being meowy. Right. I'm going to open up what wifey has done, and that way I can copy off her homework. Because academic integrity is for losers. No, I don't mean that. I'm sorry. I do not endorse non-integral academic behaviors and processes. The physical stack up should be the same, but I just want to make sure. Alright, I need to go check on what's going on. I will be right back, and I'm going to down the monster and get some water. I'll be back in like 5 minutes. What? I'm back. I need a better BRB screen. Hi, sorry about that. I have water now though, so maybe that'll fix my headache. This can fix me. Oops. What even was I doing? I don't remember what we were doing. Checking stack up against the other thing. Yeah, that's right. Aki-nyan, okay. I'm pretty sure these stack ups are identical. Oops. Cancel that. Yeah, there's a big solar flare on the ingress. Oh. You should. Excuse me. Yes, you should get some EAP. I should apparently get some EAP too. I don't even remember when I had lunch. It's 13:18 now. I had lunch. When did I have lunch? I have no idea. Good night, Bester. Yeah, okay. I think these are mostly the same. Alright, that's fine. Alright, 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 alright. Alright, 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 alright. How wide is that? What is your width? You are 0.4. No? There's no 3D printing going on here. 0.4 millimeters. And then you come out of a via chunky. No, it's hardware. There's just no 3D printing. We're designing a PCB. In this case, this is a connector PCB that plugs into a Phi PCB that plugs into the main squishy PCB. Oh, yeah, sorry, that's the AC. It was getting way too hot in here. I had to... Yeah, I had to turn on the AC. Because it was like 70 or 27 degrees Celsius right by my desk, and I was melting. Yeah, but it's not a modem switch hub something. Well, it is a something. So you were close enough. Close enough for government work. Right, okay, right. All of these need a via. They need a via, and the via needs to be, how far does the via need to be? I'm going for design consistency here, 0.6 millimeters. Alright. So what I do, 0.6, and now I have a baseline, and now I can just stack all these ground vias here. Stitching the ground plane together better than a pair of jeans. Because we got that signal integrity flow. Or something like that. I don't know what I'm talking about. If anyone tells you they know what they're talking about, they're lying. No one actually knows what they're talking about. At least I'm convinced that's the case anyway. Although that might just be self-delusion. Who knows? Because I sure as heck don't. Which proves my point. Hello, girl. I have an Annie in front of me. Annie being a little baby. A little baby. Right. She messed with... There's a... zone fill. Ground on NCU2 was turned off. We turn off ground on NCU2. Right. So then what we do is we have... No, that's not right. Alright, I need to interrogate the stack up. Oh god, my guys. Okay. Alright, so this is ground. We are in NCU1. FCU is also ground. NCU2 has turned into term power. Okay, that's what I was curious about. And then term power is just sewing machine stitched right into there. And then there's also the 3.3 volts for the EEPROM program. The EEPROM. Wah. Right. Okay. So... Yeah, 21242. 21242. Although I can just have that up there. And then what happens is this pour needs to switch from NCU1 to NCU2. Right? So that does that. And then what I need to do is go onto this one. Yeah. Create a pour. This pour will be on NCU2. We are not 3v3, we are term power. And then 21242. That is good. That is what we want. We are copacetic. Boop. Boop. Alright. Do that. Run the pour. And then I need to stitch these together. Yeah. Those are all getting stitched. What size via is this? This is a 4.52. What? Oh, fuck off. Why are you doing that? I appreciate that, but you shouldn't be doing that. Who fucked up my settings? Snap the pads. Is that it? Why is that snapping? That shouldn't be snapping. Why are you snapping? No, you're fine. Forward, that's all fine. Why is that snapping? What happened? Always show snap the tracks, arc editing, yada yada yada. Show all display options. That's all fine, that's all fine. Check. Yeah, why is it doing that? If I turn it off as never. Is that gonna fix that? Yeah, okay, that fixes that. That was... alright, bizarre. Like, oops. Like, I get why it's there, but I didn't like having to hunt for that option. But whatever. 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 Alright, we are then going to doop-a-doop-a-doo, diff sense. You are a thick boy. Why are you so thick? Why are you so thick? You're not that thick on the other one. Oh, wait, no, you are. You are that thick. Okay. Boop. And then you are on the back, I believe, and then we just go... Shizwoop. Oh, you're chugging. Why are you chugging? There has been a performance degradation in KiCad. Because that should not have been chugging like that. Yeah, that definitely shouldn't have been chugging. Routed length is 25.639. What is your rapid length? Oh, yeah, you go right up there. Or segment length, 18.17. Your segment length is 16. Oh, I know why you do that. I know why you do that. Because you can. You're effectively... There. You're effectively on the wrong layer, dumbass. Nope, change your routing stance. There we go. Be a good connector. Be a good trace. Alright. Alright. Those are implicitly connected via the internal pore. Then what do we got? Now might actually be a good time to chill. Yeah, we've been going for 2 hours, 40 minutes. Do we want to stop here? Or is everyone fine we keep going? I leave it up to a vote. Right. Right. Okay. So all of these back connections are coming out. Y'all know more than I do. You think I know what I'm doing? That is a laugh. Jesus Christ, what happened? I don't know. Why are you doing that? This starting point violates DRC. Why? Why? Use net class width. Is that what's going on? What is going on? Fucking... Why is it doing that? What? Why is it doing that? That one. All of you violate DRC. Jesus. Oh, this might be... How do I turn off DRC for a second? I know. Fucking... absurd statements by the deranged, but I need to turn off the DRC bitching at me. Or at least cock blocking me. Where was that setting? There was a setting for that. Right. It's in route, interactive router settings. I want to just highlight collisions, allow DRC violations. Just for now, because I just want to see what it's bitching about. Right, it's bitching because the frickety fucking ground clearance, because we are routing a controlled impedance net, is so goddamn huge. Awesome. Right. Oh, Annie, you're being a baby. Annie, you're a baby. Hi. Why are you a little baby? Hi. I have a baby with me. She's being a little nuzzly girl who wants pets. Oh, baby. Yeah. You got attention? You know, I can't actually use my computer when you're right there. Yeah, see, that's fine. You can do that, though. Oh. Hey, baby. Smooches. Mwah. Alright, sorry about that. I had a little girl decide to, Yeah, that's Annie saying keep going. I guess I'll keep going then. I guess I will keep going. Are these vias? Are these really the vias we used? They're huge. I guess the impedance discontinuity caused by this ground clearance is not going to be a huge deal breaker. Like, we're controlled impedance within plus minus 5%, so it should be fine, and it's not like we're operating at gigahertz here, so... While reflections are bad, I don't think it'll be entirely devastating. But also, this is the Centronics 50-pin connector. I don't know that you're gonna find it for HVD. I don't know you're gonna find an HVD device that cares that much. In fact, I don't know what the impedance for HVD actually is. We should run that. You should be net classed. You're not net classed. Why are you not net classed? That's not correct. Why are you not net classed? I know why you're not net classed, and it's entirely my fault. Right, okay. We're gonna have to do this again. Close project. That wasn't the project I wanted to close, but it will do. Want to close projects. And then we open up the text editor again. We're editing KiCad files in VS Code again. Yeah, sorry, I make sounds. I might have something wrong with my brain. The doctor said there is something wrong with my brain. Yeah. So I think this net class pattern stuff is what I want. I have no idea. I just exist and get grumpy. That is all I do. Although what I should also do though is get food soon. I'm kind of hungry and I don't remember when I had lunch. Good vibes, only vibes? Yeah. No brain, only vibes. No. And this was the one we were ripping the homework from, so that's fine. Right, okay. Oops, nope. I want to keep that open. Alrighty. I don't want the PCB. So I want you, and then I want all of you. Squishy connectors, updated net class, pattern to be actually correct. Oops. Oops. No mercy, only violence. Right, okay. So da ne. Let's try that again, shall we? Open projects. Oops, that is... Well, yeah, okay, that's working now. That's what I wanted. That's what that's supposed to look like. Safety compliant? Safety compliant with what? Are we talking like ROS compliance? Or OSHA compliance? Or National Fire Code compliance? Yee to which one? All? I don't know that we... Yes, in theory. We're not designing anything too particularly dangerous, and I don't anticipate any lead, so we're good, and... No, it's fine. You're fine. I am incredibly tired, and when I'm tired, I'm very blunt and literal. It's not your fault, I'm just bad at this. Right, okay. What I will do then... what we'll do is we will adjust all of the PCBs, because what happens is we've got to do this, we've got to turn this off on InCU2, right? Then we have to change this from InCU1 to InCU2. And then we have to draw something here on InCU2, which is term power. And that is something I have to check on the other one. I don't know if I turned off the upper atmosphere, as it were. Top copper. Top copper was what I was looking for. That's the word. Words are hard. Words are hard and none of it's real. Why are you angry? Layer isolation. Is that because your zone priority is entirely fucked? What's your zone priority? 1, 5, 4. Happy? Are you happy? Are you Daijobu? Are you copacetic now? That should be fine in theory. I don't actually know. Maybe? Maybe? Looks like you are on priority 1. You are flowing around that, and you are also, you're on priority 0. Yeah, that's what you want to be. You want to be priority 0. I fucked that up. You want to be priority 0. Okay. And then that solves all my problem. Well, it solves a problem. The other problem we have is actually tying those together. Oh yeah, this ground is absolutely Swiss cheese. I love Swiss cheese ground. Don't you? Those are huge. Why are you so big? This is probably entirely going to have to change, but if we're doing all of them, we'll do all of them. So, you know. You know. Alright. And that should be all happy, all stitched together. Alright, that's one board down. Now we have to do the other ones. The other ones. And another one. 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 You want to be on zone 0. I also didn't check if I turned you off on front copper. Yeah, no, you're good. Front copper is kosher and you are properly flowing around that. So that's all happy. That's all copacetic. Open a project, switch the project, select the project, I am losing my mind, I apologize. You are on that one. You are no longer on that one. You are a poor on that one. From priority 0. Term power on there. Alrighty. We're just kinda chilling, kinda vibing, you know? Taking it easy. For that. Do some via stitching. Get low impedance. Alrighty. And that clears up a bunch of these term power ones. I wouldn't want to send 2 amps over 2 of these spindly little pins, but you know, whatever. 2 amps at what, 5 volts? That's not that much. Relatively low voltage. In theory. All of this is just in theory, though. Do we actually know anything in practice? Probably not. Probably not. Sorry, I know this is incredibly dull, and I'm just here talking to myself at this point. But I enjoy all of your company and support. It means a lot. And I hope you're all having a good time. Or at least as good a time as possible. 'Cause I know things are rough. But we're all doing our best. Oh no, basic, I'm so sorry. Nah, if you have fun writing basic, by all means, knock yourself out. Oops. Yeah, true. That needs to change, and I'm pretty sure that's changed in the other one. Oh, I can't see shit with that on. No, it's not. Oops. Oh well, that's a power plane now. My stack up's wrong. Oops, you're accidentally a power plane. I need to, speaking of assembly, I really need to poke at that 8051 backend for LLVM again. That has been on my list of things I need to do. I don't remember why I was doing that. Oh, I remember why I was doing it. The stupid Cypress FX2 chips and all of that, their related ilk, all have embedded 8051 cores. And I didn't want to use SDC or whatever the fuck that compiler was. Apparently, since Infineon bought them, they the Cypress chips got to inherit the Infineon license for ARM cores. So apparently, the new FX3 chips all have ARM cores in them. Yeah, maybe when Squishy's done, that'll be my next series of stream stuff. Writing an LLVM backend. Isn't that just an enthralling proposal? Yeah, more expensive though, but also, 8051. Open project, connect the modules, boop-a-doop-boop, boop-a-doop-boop. Yeah. You've had your fair share of digging into LLVM code. Yeah, I know. I know. LLVM is... well... yeah, that's all I'm gonna say about that. It's a thing. I try to be diplomatic. I'm not one for drama. I like all sides to be fairly represented. I'm just not afraid to call things batshit insane when they are. Is that all flowing? Yes, that's all. That's all happy. Right. Term power vias. Boop. 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 Oh, I don't know if any of you heard recently, but Blue SCSI V2 got relicensed under the CERN Open Hardware License, strongly reciprocal, so that's cool. Yeah, that's being fair and balanced. Calling vendor tools absolute piles of steaming garbage is fair and balanced. Because it's true. There's nothing controversial about that statement. It's just an objective fact of reality. The sun will rise, etc. Yeah, LLVM is rough to work on. I'm sure it has its perks, but it's painful. A few years ago at a previous job, I was working on adding a backend to LLVM for a different platform, which wasn't... it was x86, but it was weird x86. The HPE Nonstop OS, in case anyone is curious. It was called Guardian, and then there was the open system services built on top of that, and it's just, yeah, it's rough. What was I doing here? I completely forgot what I was doing. Right, okay, that's fine. Well, It was not the x86 backend, it was an operating system backend, because I had to change out how the ELF files worked because they used non-standard ELF files. They fucked up the ABI. Oh, someone knows about the nonstop. I'm sorry. Yeah, they're rough. I do not like them, Sam. I do not like nonstops one bit. They're neat in theory. In practice, they're an absolute disaster. Like, for instance, Guardian, the, so it has a whole thing with its, file names, right? File names and directories. The problem with it, being the great equalizer, if whatever. The problem is directories don't exist. And files don't exist. And what I mean by that is you can't enumerate your directories. Like, you can't do an ls. You have to know where files, you have to know which directories exist and what files are called exactly, because directories are entirely ephemeral. If you typo a directory, it will move you to that directory because directories aren't real. And then the file names are all effectively only eight characters, only capital letters and numbers, and the $sign. I think that's it. Nothing else. Oh, Annie! Hi, meowie baby. Sorry, Annie wants attention now. Annie being a meowie baby. The point is, it sucks. The entire nonstop is a pile of garbage. And the fact that banks and stuff use it terrifies me. What terrifies me even more is that there's code that I've written that is running on banks and doing replication for all their data shit. I do not like it. It makes me anxious. Yeah, I guess it's fun from an outsider's perspective out of just morbid curiosity. But yeah, he's not Daijobu. Oh, there's also a really jank-ass PowerShell script I wrote that's doing cluster failover for the Canadian health system. I'm not even Canadian. But they were one of our customers, and I had to write Windows clustering failover software for our software suite. And, well, assuming they're still a customer and using it, that's cool, I guess. I don't know how to feel about that. Yeah, that should be fine. That should all be Daijobu. That's all copacetic. Oh god, Flex. Yeah, I know about Flex. Oh, yeah, it started with a T. It wasn't like the entire of Canada. It was one specific one, started with a T. I can't remember the name. I know they were in a controversy not a few years ago. I can't speak. I apologize. It's just easier to say, oh, the Canadian healthcare system, you know? Something? Yeah, I don't remember the name off the top of my head. Unfortunately, or fortunately, whatever. Maybe maybe telehealth? I don't know. It was a prescription scandal they were involved in. That scandal was not my doing, by the way. That was not a result of my code. That was before I wrote code for them. I promise. It says Aki for legal reasons, yeah. Entirely for legal reasons only. I tried to get a job at Keysight during the pandemic. I taught the person on that was doing the technical interview something, and then I never heard back from them. I taught them about the double XOR variable exchange. It just came up in conversation, and then I never heard back from them. So that was cool. But at least I didn't have to move to New Jersey. So, you know, there's that. I am still absolutely pissed off at Canonical. I mean, maybe me getting the job there was for the best, not getting a job there was for the best, but I did what, 4 or 5 interviews with them. I got to the final stages, and then they went with someone else after saying, like, yeah, you're probably a shoo-in. It's just, it was exhausting. I tried to get an interview at Red Hat. They never got back to me, nor did Seuss. I got rejected outright or ghosted. It was not fun. I got ghosted from Calabra too. And Igala. Never heard back from him. And Oxide. Oxide ghosted me too. I've been out of all of my job applications, I haven't gotten a single one since 2018, and I've been ghosted for 99% of them. It's gotta be me at this point. Anyway, that's why I'm a NEET. Cause I fucking can't get a job. I don't know, probably better than mine. I don't know if I should apply to Red Hat again. I don't know how that would end. Also, my mental health at the moment is probably not the best for a normal job. Oh, you got auto-modded, sorry. Apparently asshat, automod thinks asshat's a bad word. Oh, oof, that's scummy. Maybe I got off light with the canonical stuff then. Yeah. I hate capitalism. I want that fully automated gay space communism. Capitalism sucks, man. Just fucking sucks. It's so hard. Yes, I agree it must first be built, but unfortunately the capitalists are, capitalists and the fucking tankies and all of them are in the way. And I don't want to go all Mao Zedong on it, but, you know, sometimes it's tempting. Anyway. Oh, I'm sorry. Yeah, those who shall not be named. Oops, that's not what I wanted to do. We're almost there. We're almost all up to speed, and then I have to go back through and probably massage the connectors a bit. But that would probably be enough because it has been. Oh, you're apparently locked. Beep bop boop. I don't want to think about Monday. I have to solder a bunch more Glasgows. There's still like 1,000 left! Did I do the vias on that last board? I don't actually remember. I will have to go and check to make sure I did the transfer vias for return power on that last board. Also, I have licked one of the Glasgows. I will not tell you which one, but I have licked one of them. That has gone out to a customer. No, that's a joke. I haven't actually done that. It was tempting, though. It was very tempting. Why do you regret getting one now? Oh, not getting one. Yeah, I've probably done close to almost 500 Glasgows so far, and there's still like 1,000 left. It's not going super fast, because I can only get anywhere between 50 and 60 done a day, and I'm only helping out 3 days a week. So, you know, it is what it is, but... it is what it is. Yeah, it's actually, it's pretty nice. Minus car troubles. I'm just checking to make sure I put the transfer vias in here. Yeah, I put the transfer vias. Plus, oh, I love using a JBC soldering iron. It is so nice. They're expensive, but Jesus Christ, it's so much better than the jank-ass Hako I have. Was this the last one I did? Oh, it's not the full board. The panels are assembled. I'm just doing all the through-hole assembly. It's only 46, 45 or 46 solder joints per board. It's the two connectors, that's 40 plus the sync connector. Yeah, so 45 pins per board. So it's around 2,700 solder joints a day. What is soldering iron? What is soldering iron? I did not. No, I have not heard that. Apparently the Metcal people, the old OG engineers from Metcal left and went and formed their own company and are offering Metcal compatible irons, but are so much cheaper. I don't know what they're called, I can't find them, but apparently that's a rumor that's going around. And that'd be great, because I'd love to get me a really good iron. Because I need a really good iron, but they're all so goddamn expensive. Like JBC, the station itself is like 600 bucks, and then you got the handle for 50, and then all the cartridges are 60 bucks. Like, Jesus. But the JBC irons are so nice. People say it's not the tools. Tools don't make the craftsman or whatever, but with soldering irons, it kind of is. You can make do with a cheap-ass soldering iron, but it is so much better to use a proper good one. Maybe I'll put a JBC station on my throne. It's not like anyone ever funds throne gifts anyway, but you know. A girl can dream. Yeah, that's correct. Ba-da-ba-da-ba-da-ba-da-ba-doo. Ba-da-ba-ba. Oh, I'm so tired. I'm so tired. Maybe we're gonna breach 4 hours for today's stream. Sound good? 4-hour stream. Why stop at 4? Go for 5. Oh, meow? Annie? I heard a meow. Hi. Oof, that sucks. Alright, I think this is the last one before we go through all the connectors and wiggle those to... No, I was just there. I was just in this one. This one. Which is not one we're going to... whatever. This isn't going to technically be one of the supported ones because of how things are turning out, but we might as well just make the changes consistently. Because consistency is king. Turn power. Just kind of vibing, you know. Meow. Sorry, was responding to Annie. I don't know if you heard her. She wants attention. Because she is a cat. She has the zoomies. She's zooming up and down. She wants attention. she's grumpy. I'm ignoring her. Yeah, I might have to stop at 4 because I'm starting to get lightheaded. I'm probably hungry. Well, not at 4, at 4 hours. That would be 30 minutes, 40 minutes. So yeah, that's probably the plan. We'll stop at 4 hours even. So in 40 minutes? Yeah. Just about. That's the plan. Aki-nyan. Just run it through an OCR. Easy peasy. Or are you talking about like understanding and documenting the code? Yeah. Oh. Oh, it was OCR'd and it's entirely fucked. Okay. Yeah, no, I get that. I understand that well. It's a purveyor of old documents. Oh, okay. Yeah, okay. I think... I need to figure out why there's 3 minutes of silence at the end of that song. Sorry. Alright, close project. We will then re-wiggle all of these. Drawing circles ain't easy. Nope. Alright, that was this. Squishy. Connectors. Fixed the poor layers. Fixed poor layers and added turn power. How the fuck do you spell stitching? Stitching. Stitching? There we go. Got it. I got it eventually. For all EDSCA. HPD 50CE. Oh, hi, small cat. Hope you're doing okay. Hope you're having a good day. We're just having a chillax stream right now. Just bapping at stuff. Alrighty. Oh, big stretch. I finished off all my water. I might cut that early. I am lightheaded and hungry, so we're probably gonna just make it for the next 3 minutes and then cut off at 3 hours 30 minutes. That's not too bad. That's, you know, not too bad. Let's look for someone to raid. Let us look for some. Oh, that was the wrong one. Who do we want to raid? Who's streaming? Is there anyone streaming? Is there anyone streaming? Is there anyone I know that's streaming? I don't think so. I don't want to raid someone I don't know because I don't know if they're comfy or not. So I am open to suggestions. Otherwise, we're just gonna have to call it. Which I don't want to do. I want to spread the love. But what are they doing? I think... Sure. But let me make some adjustments here. Boop. 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 Oh, okay. Well, if people are cool with that, then we will do that. I forget how to use Twitch. Boop. Let's do that. So we'll do that. Thank you, everyone. It was a pleasure. I will have to remember that name for next time. Shock attack. But yeah, I will see you all around. I hope you all have a good day. Thanks for joining. And yeah, we made some progress. So I will try next weekend. And hopefully we'll make some more progress. And some more progress. And some more progress. And progress will be relentless. We will consume all. Alright, I hope you all have a good day. Have a good one. Bye.